Got your homework. I'm ready now. Number 8. Y equals x squared e to the x minus x e to the x. I'm going to do product rule on these. Derivative of the first would be 2x times the second plus the first times derivative of the second. Derivative of e to the x is just e to the x. Minus, and I am going to do parentheses because I'm going to have to subtract all of this whenever I do product rule here. So derivative of x is just 1 times the second plus the first times derivative of the second. And the only thing really you could do here, might do this, is maybe factor out an e to the x. And then let's see, then there might be some like terms. Let's see. If I take e to the x out, it leaves me with 2x plus x squared minus 1 minus x. I can combine those two. X squared plus x minus 1. And that's really all I can do. Does that make sense? Y'all good? Give me another one. 17. Natural log of 1 over x. Hold on. All right, derivative of log is 1 over. I'm actually gonna rewrite this as this way because I think it'll help you see what's going on here. So I do 1 over whatever's in the argument of the log, right? So 1 over x to the negative 1 or 1 over x times, now I have to chain it. So what's the derivative of x to the negative 1? Negative x to the negative 2, that's exactly right. Right? And now I just clean it up a little bit. So I've got a negative. This one actually goes to the top. This one goes to the bottom. Might help you see it that way. So this becomes negative 1 over x. Does that make sense? What else? No, the domain, no. No, we're going to talk about it. What did y'all say? I'm sorry. 18? Y equals log of 10 over x. Again, I think I'm going to rewrite this as 10x negative 1 just to kind of help as I find the derivative. So derivative here, so 1 over 10x negative 1, and now I need to chain it. So what's the derivative of 10x to the negative 1? That's exactly right. I do have a negative. Let's see, the 10 will be up top, and actually I can do this. So now I have all right, so I'm going to move this one up and make it x, and then this one I'm going to have 1 over x squared, negative 1 over x squared. So again, I end up with negative 1 over x. Hey, those came out the same. Just homework questions from whenever I saw y'all last. I don't even remember. 33? Don't worry about the domain on those, Avery, on that last part. Yeah. 33. 33 is one that looks terrible, but it's really not terrible. Find the derivative. I'm going to use power rule because this is just a constant, right? Pi times x. That's it. That's it. Yeah, treat it just like it. Yeah, just like any other. That's it. On 33? No, don't do that. No, we're gonna do that for some things today, but not for this. That's too easy. Which one did you say? 22? Y equals log base 5 square root x. All right, so derivative of a log. 1 over x, so 1 over square root of x, times 1 over the log of the base, which is 5. But now I chain it. So I'm looking for the derivative of this, which is 1/2 x negative 1. Looks like everything's going to be in the bottom. 1 over, I've got square root of x, log 5. I'm just going to write it this way so you see everything. 2 square root of x again. So we'll put together what goes together. Square root of x and square root of x become x. There's just 1 over 2x. What was that? Oh, 25? Sure. Just make sure you can simplify there. Because if it was like a multiple choice type question, it would be there. But yeah, you have to chain. Whatever follows the log argument, you always have to chain that. Which one did you say? Somebody said 125. Log 2 times log base 2 of x. So I'm going to do product rule here. Derivative of the first, right, times the second. Oh, I didn't finish writing it. What is that, an x? Times the second, plus the first, times derivative of the second. Oh, this is silly. I didn't even have to do all that. It is a constant, yeah. This doesn't need product rule. I mean, it's not wrong that I was doing it, but I mean, actually, it is wrong because that's the derivative of constant is 0. Log 2 is a constant, right? There's no variable in that. So the derivative is just, remember the constant comes out front. Now I do the derivative of the log base 2 of x, which is 1 over x times 1 over natural log of 2. Wow. Well, these cancel. Only if this is chainable, like if that's another function there that you can take the derivative of. Right, it's just 1, so. That was way easier than I was making it. Derivative of, just for the record, the derivative of log 2 is not 1/2, it's 0. Anything? 26. Ew. Log base 3. 1 plus. Oh, good. Did we do this one? Okay. Well, there was a lot of you not here. We'll work through it. All right. So, lots going on here. It's just a big chain. It's got product in it. Okay, first I'm gonna do the derivative of the log base 3. So it's 1 over 1 plus x log 3 times 1 over log 3, right? That gives me the derivative of the log. Now I need to work on the chain. So the chain says take all of this and find the derivative. Okay, so times, the derivative of 1 is 0. But what's the derivative of x log 3? Log 3. Why is it just log 3? Because it's a constant. Does that make sense? I could write it as log 3 x. But log 3 is just a number. If you put it on your calculator, it's just a value. There's no variable in there. So no need for product rule, like I said again. Do it again until I caught myself. These cancel. Logs usually look worse than what they are. What else? 40 what? 42. F of x equals log base 10 square root x plus 1. So derivative here is going to be 1 over the square root of x plus 1 times 1 over natural log of 10 times, now chain it. So I'm looking for the derivative of this. 1 half x plus 1 to the negative 1 half. And now if there was a derivative here, I would need to chain it again. Or if it was derivable there, anything other than 1, I would need to chain it again. Differentiable. There's the word I'm looking for. All right, so let's put it all together. I've got 2 square roots in the bottom here again, right? This is the same thing as 1 over square root of x plus 1. And when I multiply those two things together, the radical just drops off. So I really have 2 times x plus 1 times the natural log of 10. Right? Yeah, that's all I can do there. That's it. Feel good? Anything else? Okay. Y'all ready to do logarithmic differentiation? What time do we get out of here today? 55. Y'all aren't going to like this, I'm sorry. The last thing that, okay, so I planned on reviewing tomorrow and testing Friday, but y'all aren't going to be here tomorrow. Dang it. Y'all don't be late for that now. You didn't come yesterday? I don't blame you. Hope I heard you left early. Yeah. But I did get a 25. You got a what? 25. What? Was it hard? I really. Yeah. Did the videos help you though with the inverse stuff? Just showed like proof that the derivative of like or like the inverse derivative of like that you know what I mean? Let's talk about logarithmic differentiation. Y'all ready? So ready. Remember those three properties I told you about logs? The main one we're going to use is that one that one of you said that was your favorite. You remembered it, where the power comes around front. You know what I'm talking about? All right, so let me show you why this is helpful. Let's say I have something like, this is the very last thing too. I'm just going to use a, like this. Okay, what if I had to find the derivative here? I'm in a bit of a pinch, right? I can't do power rule here necessarily because what am I going to do? That's not a constant really for the derivative grows, right? So what I can do is called logarithmic differentiation. And essentially what it does is I take the log of both sides. It can be log, it can be ln. Generally we use natural log because that's just the more accepted. But I come in and I do log of both sides. And then what I'm going to do is I'm going to apply that power property. I'm just going to say apply log properties because depending on what it is you have, depends on the property that you would apply. So in the case of this one, I would take the exponent and come around. Okay, so I have, this would be the natural log of y equals log x times the log of x. Y'all okay there? Now, how does this help? And I could actually make this if I wanted to. I could say this is log. I wouldn't put the squared here. I'd do the squared like this because as I start doing derivatives, I'm going to have to worry about chain rule. But this helps because now if I take the derivative, okay, it becomes an implicit differentiation problem. And the reason is because on the left side, I'm going to have to take the derivative, right? What's the derivative of log y? 1 over y, but because I'm taking it with respect to x, I have to follow with a dy dx. Now what's the derivative over here? Power first, and then chain it. Now I still haven't found the derivative. What I needed to find was dy dx. So same as I did with implicit differentiation. I multiply both sides by y here. So dy dx equals y times, and I'm going to just make this 2 log x over x. I got rid of it here. Multiply by y on both sides. And I'm still not done because I need dy dx and the y is still there. What do I do? Plug in the original y. What was y originally? X to the log x, right? So this becomes, and I should probably say that over here, little steps. I was apply log properties, solve for dy dx, and replace y with your original y. Oh, no. What was the original y? I shouldn't have written it. It was just x log x. There we go. Sorry. That's it. You okay? Let's see if you can do it. Let's do an easy one. This is actually number 50. You try this one. See if you can get it. Use logarithmic differentiation to find dy dx. Caroline, congratulations on y'all's. Did y'all win? Greer, how did golf go? You don't find out when you play it? Oh, okay. Oh, I gotcha. Cool. That'll be good. And then y'all go to state if you are? Or that was state. That's awesome. You ready? I heard volleyball did really good too Monday night. That's what Miss Wharton came in and said. It's good though. But y'all won the set, right? The game. I get confused. On what we call it. Oh my goodness. Scare me to death. It's okay. I need a juice. All right, y'all get it? I'm all talking and log both sides. So I have log of y equals tangent x log of x. Right? Because I brought that tan x right around front. Power rule. All right, so I got 1 over y dy dx equals derivative of the first was derivative of tan x secant squared x times the second plus the first times derivative of the second was derivative of log x. I'm going to multiply both sides by y. So dy dx equals y times secant squared log x plus, I'm going to probably make this tan x over x. And now what was y? Y was x to the tangent x times secant squared log plus tan x over x. I'd probably leave it like that. I mean, you could give the first one an x top and bottom and combine them over the same, but I'm probably stopping there. Do I? Trig and logs, yeah. Y'all want to do one more? Or are you okay? Okay, but a couple of them are going to get a little bit longer. Like 51 tells you to use logarithmic differentiation, and this is what it looks like. Right, yeah, logarithmic differentiation. Well, but if you think about your log properties when you do this is really to the 1/5 power, right? So if I log both sides, I'll just help you get it set up because you got another one that looks very similar to this. And then I start using all these log properties that I know. First one being the exponent. Now I have x minus, drop the log. Now I know that whenever I'm dividing, I can subtract, right? So this is really log y equals 1/5 times the log of x minus 3 to the 4th. And I'm even going to split this up since I'm multiplying. Plus x squared plus 1 minus, because of the division, and you can even distribute the 1/5 through to help you out. So log y equals 1 over 20. Nope, just kidding. 4/5. Now you can take the derivative a little bit easier. They look bad, but they're really not bad because this is just 4/5 times 1 over x minus 3. 1/5 times 1 over x squared plus 1. Chain it. Don't forget the chains when you do this. Chain. Then it becomes a little easier. I'm not doing the derivative here. For the derivative, yes. This is a log property power rule. It gets quite, I'm sorry, it gets a little confusing. But yes, you would if you're doing derivative, yes. You want me to do it? 1 over y dy dx equals. No, none of that was derivative. All I was doing was getting it situated with logs. Now I'm doing derivative. So remember, it's log. Again, these are just log rules. If it's like this, I do log base b of a minus log base b. All right, so I have 4/5 times 1 over x minus 3 plus 1/5 times 1 over x squared plus 1, but I need to chain it. I'm doing the derivative now. Implicit differentiation here. And chain. 4 over 5 times x minus 3 plus 2x over 5 times x squared plus 1 minus 6 over 5 times 2x plus 5. Now all I have left to do is multiply by y on both sides. And whenever I do that, I actually want to plug in what did I start with? The fifth root of, I'm just going to copy it straight from x minus 3 to the fourth, x squared plus 1 over 2x plus 5 to the third times all of this. It's not really hard. It's a lot to write, but it's not really hard. Praying for those trigs now, aren't you? X to the 10x doesn't seem so bad when you do one like this.